Hey, Vsauce, Michael here. The Earth is spinning, and we are spinning along with it. But what if the Earth suddenly stopped spinning? Well, first of all, you would gain weight. But that would be the least of your worries. The spin of our planet is important and literally giving you the time of your life. At the equator, the surface of Earth and everything on it is spinning around at 465 meters a second. As you move closer to the poles, you don't have to move as quickly to complete Earth's daily rotation. Here in San Francisco, the Earth is driving me east at 368 meters per second. If I could float above the surface independent of the Earth's rotation, the Earth would spin underneath me this quickly. Pretty cool. But of course, when I jump straight up into the air, the Earth doesn't move underneath me because I continue to spin with it. We are all spinning with the Earth, and that is why slamming on a set of magical planetary brakes that caused everything classically called Earth to stop spinning would be catastrophic. Immediately, everything that wasn't Earth and wasn't safely at the poles would continue moving as it had been and be flung due east at more than 1,000 miles an hour. You wouldn't be flung into space because escape velocity is 24,800 miles per hour, but your body would instantly become a 9.5-inch caliber bullet. Well, really more of a supersonic tumbleweed. Because the atmosphere would more gradually slow down, people in airplanes, assuming they could navigate the resulting storms, might have a better chance of surviving. Astronauts aboard the ISS would fare even better, but it is unlikely that anyone would be waiting for them down on the ground. Runways would just be entrances to the new planet-sized graveyard created by the no longer spinning Earth. People really near the poles might be okay, but only at first. Gusts of wind as fast as those near an atomic bomb detonation would blast past the surface and up into the sky, forming worldwide storms of unprecedented magnitude. The friction alone, caused by the now stopped Earth colliding with these winds, would be enough to cause massive fires, unparalleled erosion, and damage to anything strong enough to stay put after the initial braking. The sun would seem to freeze in the sky as days became not 24 hours long, but 365 days long. Without spinning innards, Earth's protective magnetic field would cease to exist, and we would be dosed with deadly amounts of ionizing radiation from the sun. The oceans would surge onto land in tsunamis kilometers high and wash over nearly all dry land before migrating to the poles, where gravity is stronger, no longer held to the ocean basins by the inertia Earth's spin gave them, until Earth itself, no longer bulging an extra 42 kilometers around its equator because of its rotation, slowly compressed into a more perfect sphere than it is now, possibly allowing the oceans to eventually return somewhat. That is what would occur if it actually happened. It won't actually happen, but whoa, its rotation is slowing down. More on that later. First, if the Earth really is spinning so quickly, why can't we feel it? Why doesn't the Earth's rotation make us dizzy? Well, lucky for us, the change in velocity is just too gradual. The Earth is too huge. It's like driving in a car that takes 6 hours and 6,000 miles to make one left turn. It's not sudden enough to register with our senses. But that change in velocity is real, and it makes us weigh less because of inertia. On our spinning planet, your velocity is constantly changing, but always tangential to the circular path you are being dragged along. Now, because inertia is a property of matter, which includes your body, without a force acting upon us, we would slowly leave the surface of Earth. Luckily, the Earth is exerting a force on us, a center-seeking centripetal force delivered by gravity. The centripetal force required to keep you along a circular path with Earth is subtracted from Earth's total gravitational pull on you. The remaining force simply pushes you down toward the center of the Earth. It gives you weight. At the equator, if the Earth didn't spin and no centripetal force was required to keep you with the Earth, you would weigh 0.3% more than you currently do. If Earth spun you around 17 times faster than it currently does, all of its gravitational force would go towards centripetal force fighting against your inertia, and you would be weightless. So here's a diet idea. Hope that the Earth starts spinning faster and go back for guilt-free seconds. We know exactly how long a second is. The outermost electron of an atom of cesium-133 is alone. When the atom is undisturbed, only the nucleus interacts with this outermost electron, tickling it regularly and rapidly between two levels. After 9,192,631,770 oscillations between those two levels, 1 second has passed. Exactly. That is literally the definition of a second. We can measure and count those oscillations. It's how atomic clocks work, making atomic clocks the most accurate measurement device ever built by humans to measure anything. We can't define a second more simply as, say, 1/60th of 1/60th of 1/24th of a day because of Earth's spin. It's too irregular. Little changes in the distribution of mass on Earth caused by earthquakes or melting ice or man-made dams, or technically even you walking upstairs or downstairs, cause Earth's rotational speed to change, like a figure skater moving their arms further away from or closer to their bodies. Now add on top of that the fact that tides caused by the moon drag against Earth's rotation, and you wind up with an unstable rotation speed that is predominantly slowing down. Now, these changes are incredibly slight, but over time they add up. In 140 million years, a day on Earth will not be 24 hours long, it will be 25. That might not sound like much, but in order to do important things like deliver accurate GPS information, we need a more accurate timekeeping device than that. So as a solution, scientists keep the pace of seconds using atomic clocks, TAI time, and other scientists measure the changing speed of Earth's rotation by observing distant stars and quasars. Now, every few months, they find out just how behind or ahead Earth is running, and if it's getting too close to being a second off, they decide to add or subtract a second from the current year. The result is the time used almost everywhere, including your phone, UTC. Since this system began in 1972, 25 leap seconds have been added. What this means is that clock time is and has to be a manufactured product with upgrades and tune-ups administered periodically after defects are noticed. The time we give to now and the future is only ever approximate. That's weird, but it's also entirely not weird. As Demetrius Matsakis, the chief scientist of time services for the U.S. Naval Observatory, puts it, we save lives and we end lives. We add time and we can take time away, but in both cases we do so without completely understanding exactly what life is or what time is. Regardless, thank you for spending some of yours with me, and as always, thanks for watching.